All right. The parallel circuit. So all the same things, but now we're looking at a parallel. Again, this is not a complex circuit. This is a straight parallel circuit, so you can apply the rules to the whole circuit. Calculate the equivalent resistance. Well, in parallel, total resistance is a little funky, right? It's the 1 over R1 plus 1 over R2 plus 1 over R3, all to the -1. That's going to give us our total resistance there for parallel. And so it's going to be 1 over 24 plus 1 over 8 plus 1 over 12, all to the -1. And I do that out in my calculator and I get 4 ohms. All right, total current. Now it's the same thing as a series. Now that I've reduced it to one, resistor, it's just V equals I times R for the whole thing. I can see that it's 24 volts. All right, current's what we're looking for, and the resistance is 4, so it's a current of 6 amps. All right, current through each resistor. Again, I can use the table here because I know it's parallel. Voltage total equals the voltage across 1, which equals the voltage across 2, which equals the voltage across 3. So voltage is the same. And so if it's 24 volts there, then I can put 24 all the way across the table. All right, we found that was 4, and we found that was 6. Now, I'm just divide the voltage by each of the resistances to get the currents. So for each of these, again, it's V equals I times R, but now I'm doing I equals V over R for each one. So 24, that's going to give me 1 amp. 24 over 12 gives me 2 amps. And 24 over 8 gives me 3 amps. And sure enough, 3 plus 2 plus 1 is 6. They do add up to the 6 amps there in the bottom. All right. All right. So power for the 8 ohm. Which one's the 8 ohm? There we go. R1 is the 8 ohm resistor. Same thing as series. Voltage times current. That's not a different equation for power once you know the voltage and current through an object. So power is going to be 24 volts times the 3 amps. And that's going to give me 72 watts, 72 joules per second flowing through that. And then total power by the whole thing. Well, the whole thing, again, we'll grab that bottom. Power is voltage times current. So that's going to be 24 volts now, but now we're doing 6 amps of current, and that's going to be 144 watts coming out of the battery there. All right. That's it.